So I gave you a preview, for those of you who went to New York last year, I gave you a preview of this. So let's talk about RIST multicast discovery, which is TR064 part 5. Sometimes I even confuse myself with all those numbers. So our agenda today is we'll define the problem, the VSF-TR status, which, guess what, it's approved. And then we'll have a technical discussion. And we do everything for users, right? So we're going to show use cases of this TR. So what is the problem we're trying to solve? We have native support in multicast in Simple Profile, because Simple Profile was based on RTP, and RTP supported multicast. So we've been multicast capable since day 0. You can also carry multicast over the RIST tunnel. So if you have a RIST tunnel between not multicast enabled networks, you can carry multicast over a RIST advanced profile, RIST main profile, or WireGuard. In fact, some of the flows you have downstairs coming from the outside world are inside their multicast. In some situations, a device may be sending multicast traffic with nobody caring. So it wastes bandwidth. And we want to have the traditional multicast workflow in the internet. Or, in other words, if nobody cares, just don't send the packet. Well, you're going to say to me that there's plenty of multicast routing protocols that already do that. And that's true. And I used to teach that stuff. But those are very complicated, and there may be a need for a simpler solution in some situations. So that's the problem. So here's an application example. You have a RIST sender, a RIST receiver, and a wide area network link. That wide area network link is RIST main, could be a RIST main profile tunnel, a RIST advanced profile tunnel, a WireGuard tunnel, or a private link with RIST simple profile, but it's a WAN link. You have 3 multicasts coming to this RIST sender, and in this case, the RIST sender is a gateway. And the receiver says, I want multicast 3, and then it gets it. Not all 3 multicasts, just the one it wants. So pretty simple, right? So I'm stealing a page from Rick's presentation. Simple main and advanced profile have been published for a while. We have updated them recently. Well, recently in 2020 for simple profile, 23 for main profile, and 22 for advanced profile. The change in 23 for main profile was just an equation that was wrong. There was a bracket somewhere out of place, so sorry about that. And then the TR064 are the ancillary features, and they are all, there's 5 of them so far. There's more coming, and this is that one, RIST Multicast Discovery, which was published late 2023. So that's the one I'm talking about. I've had, in previous VIDTRANS, I've had talks about all of these, except for the WireGuard, which is basically a TR that says, it's okay to use WireGuard, just use it this way. So what's our technical approach? There are existing protocols to communicate multicast group membership, and you all know and love them, right? So, a lot of them. There are protocols that support group leave and join, which are IGMP version 2, RFC 2236. And there's an IPv6 version of that. And we call those GMP, Group Management Protocols. And then there's variations of those GMPs that have source filtering. It's exactly the same thing, but you filter the source. And we call them SFGMP. And why are we using that? It's just to say, so I don't have to say IPv4, IPv6 all the time. And I wrote very small. This is a good idea to use these terms, but I didn't think about that. I just copied it from some RFC. All right. So GMP review, and you are now officially allowed to take a nap if you know this. You want a multicast? You send a GMP join message. Give me this multicast. And that's the only thing you send unannounced or unsolicited. If the device that sends the multicast should periodically query the network to see if it's still wanted. So there's a timeout mechanism to stop sending the multicast if you die. So there's a timeout. And if you no longer want the multicast, you send a leave message. And that was the big difference between IGMP version 1 and 2. Back in the Stone Age, the version 2 got the multicast leave message. And SFGMP adds the source filtering. So allows you to say, I want this multicast, but only from this guy, or not from that guy. I'll give you a list. So all this stuff is at least 20 years old. Guess what? Part 5 simply requires implementation of these protocols at both ends of the link. So not a big deal. So here's an example of a node-to-node. You have a tunnel, and you have a sender and a receiver. And TR-06 for part 5 includes, you got to do that on the receiver. And guess what? That's a standard unmodified GMP stack. You just run that on the tunnel. You got to do that, a GMP query on your sender. And that's not included by default because there's a router function. But you can there's lots of open source available for that. And the GMP listener. If you have a gateway, it's kind of the same thing. Now, there's a RIST multicast gateway, and guess what? There's already a full open source package available for GitHub, which is called IGMP proxy. So if you want to implement TR-06 for part 5, you don't have to write a line of code. You can just drop that in. So we didn't even have to do that. We didn't even have to implement anything. It's done for us. For IPv4. So if any of you like to code, we appreciate an IPv6 version of that if you want. Weekend project for Monty, who's not paying attention. What about mesh networks? I got to talk about that. Part 5 provides a very basic multicast routing functionality. It's very, very basic. In a mesh network, and I made sure to write that in the TR very specifically, you require a single predefined path from the source to all the multicast networks. The traditional multicast routing algorithms are complicated the way they are because they compute the best tree and they handle topology changes. So to avoid routing loops, we require, if you're going to go for part 5, you need to determine one interface, single upstream interface. You cannot have multiple upstream interfaces, and you have to manually select that. You don't like that, drop in a routing protocol. So what happens if you don't do that? I have a mesh network, a source multicast, and a receiver for multicast name. The source sends it, the gateway sends it that way, and it gets there. Fine. But also, that gateway sends over there, comes back over here, comes over here. Oh, another copy. Oh, it goes there again. You have a loop, right? So you need to have a distribution tree. So those packets will loop forever if you do that. Can we fix it? Yes. At that point, you just walk away from part 5 and use a traditional multicast routing protocol. When I presented this at the VSF Fall, I got more questions about that. So let me be more specific for that. There's many, many multicast routing protocols available, starting from DVMRP, which is the original one written by Steve Deering when he invented multicast. It's basically a RIP with multicast extensions. You have MOSPF, which is a very interesting protocol, It's OSPF with multicast extensions. And then PIM, dense and sparse mode, dense and sparse, just meaning how you optimize if there's many, if you expect to be lots of receivers or not a lot of receivers. I need to be a little nerdy here. Given a mesh network, the multicast routing protocol computes a subtree called the Steiner tree. That includes the source and all the destinations. Computing that optimum Steiner tree is an NP-complete problem. And the multicast routing protocols always compute an approximation. The VMRP, for example, gives you a tree that is just a combination of the shortest path. I had, about 30 years ago, I had a lot of fun with that stuff. It's part of my PhD thesis, this stuff over here. And I can tell you it's fun. So traditional multicast routing protocol will provide you better network utilization and better reliability, but not optimal network utilization, because that's NP-complete. I did come up with some algorithms that greatly reduced the computational complexity, but it's an NP-complete problem. So multicast routing protocols make a difference if your network is too connected. What do you mean too connected? Is a term in graph theory that means there's at least two paths between any pair of nodes, and then any good mesh network like the internet, the ARPANET, and whatever is too connected, because you need to have redundancy. All right. So how do you use RIST with multicast routers? I got a little picture of a multicast router. And you have connections. So that connector can be a router tunnel. The routers do have tunnels too. It could be a main profile tunnel, it could be an advanced profile tunnel, or it would be a WireGuard tunnel. So in a larger network, you leave the RIST to the RIST, and you leave the multicast routing to the routers. You should not use the part 5. You still use RIST, though, on the point-to-point WAN transport, because that's very good for it. All right. Let's show you a few use cases. You have a central distribution system with a whole bunch of multicast TV channels. And you have a hotel or a hospital somewhere, maybe more than one, and you want to send that from the central distribution system, you want to send that over the internet using some sort of tunnel, right? So you drop a RIST multicast gateway in there with the functions you have, and then you have a multicast network. So only the multicast tuned by the set-top boxes are sent over the wide area network. You don't need to send everything. And this is a cheap way to do that distribution without having to buy or configure a high-end multicast router, which those things are not for the faint of heart. Okay, another case is distributed production, right? You see I started with a RIST encoder or gateway and then the internet. And I have a whole bunch of cameras. And I have a whole bunch of clients. And each editor is producing their own stream, a POV stream, and each editor can independently select one or more cameras to transmit. So they're doing their own production. And only the selected cameras are sent to the requesting editors. And you see here how happy that guy is that we did part 5. It's working for him. All right, this was a short talk. I still have, I'm going to give Brad a chance of getting ahead on schedule, but let me talk about my conclusions here. Part 5 introduces a simple optimization method for multicast network using RIST. It's really not tied to RIST. It's just a good idea. It was driven by people asking for it, but it complements the specification. So it's there for you. RIST gateways or multi-stream receivers can optimize incoming bandwidth based on what they want to receive. So essentially, it's very simple, don't send me what I don't want. For complex networks, complex mesh networks that are too connected and better, you use a traditional multicast routing protocol instead. And there's an acknowledgement from my friend Adi, who actually pushed this thing through. I got to talk about it, but he pushed it through. So when he said users want that, we just believed them and put it in a TR. And that's my talk. Any questions?
Okay, thank you.